Okay guys, so in the last class we started talking a little bit about weather. We talked about weather forecasting agencies, and what we're going to do today is we're going to have a little look at how heat is distributed around the Earth. Now you guys know that in some parts of the Earth it's very warm, like in these hot deserts. So this would be a hot desert climate, and it's usually quite warm. They don't have a lot of clouds in the sky. There's very little precipitation. In other areas, they have snow on the ground and ice for long periods of the winter. Some places are frozen in winter and in summer, such as in the Arctic and in the Antarctic. And then in other places you have this beautiful warm tropical type of weather. So some parts of the Earth are warmer than other parts of the Earth. You tend to have cooler regions down here at the poles, the North Pole and the South Pole, and it tends to be warmer here closer to the equator. So that's what we're going to be focusing on today, as to why different parts of the Earth have warmer and cooler temperatures. So from what we just looked at there, we know that the Earth is heated by the sun. We looked at that in the last class very briefly, by solar radiation, but it isn't heated evenly. So I want you to start taking down the notes now, please. So solar energy is distributed unevenly over the surface of the Earth and within the atmosphere. So what we're going to be looking at really is the surface of the Earth. Its strength depends on latitude and the tilt of the Earth on its axis. So those are the two things that we're going to be looking at. So latitude, and we'll look at that in a little bit of depth now, and the tilt of the Earth. So you might be wondering, what is latitude? Or you might have come across it in the past paired with another word, longitude. So latitude and longitude are what are used to give GPS coordinates. So what we have here are our lines of latitude. So we have here an imaginary line at the center of the Earth, and that is the equator. Everything north of the equator is the northern hemisphere. We live in the northern hemisphere. And everything south of the equator, so everything south of the equator is the southern hemisphere. So northern hemisphere, southern hemisphere. Now the equator isn't the only line of latitude. There are lots of them. So the equator is probably the most important one for you to know. And then we have our Tropic of Cancer, our Tropic of Capricorn, the Arctic Circle, the Antarctic Circle, the North Pole and the South Pole at the very edges. So those are our lines of latitude, and you'll see that they are measured in degrees. The equator is 0 degrees, and the North Pole is 90 degrees north. The South Pole is 90 degrees south. Now, at the equator, sun rays or sunlight tends to hit the Earth fairly dead on, and they tend to be concentrated. The further away from the equator you go, the greater the angle that the rays of the sun are hitting the Earth at. So they're distributed, or they're spread over a greater area, so they're not as intense. So because the Earth is spherical, so because it's round, shaped like a football, the equator is closest to the sun. So this is where the equator is, and it's closest to the sun because the Earth is a sphere. So this means that areas closer to the equator are warmer than areas that are closer to the poles. So the poles up here, the North Pole 90 degrees north, South Pole 90 degrees south. The sun's rays have a shorter distance, it's only slightly shorter, to travel to the equator, so the heat tends to be more intense here at the lower latitudes than up here at the higher latitudes at the North Pole and at the South Pole. And the sun's rays shine directly on the equator. They are concentrated on a small area. The rays at higher latitudes, the North Pole and the South Pole, they're hitting the Earth at a greater angle, and the rays are less intense. They're more distributed. So all of that again are notes. Now the other thing that helps to distribute heat and explain the way that the Earth's heating is uneven is that the Earth's axis tilts towards and away from the sun at different times of the year. So the Earth spins on its axis, so different parts of the Earth's surface are tilted towards the sun. This influences the seasons and length of day and night. And so what we have here, so we have our northern hemisphere is tilted away from the sun. So straight away I can tell you that this is winter in the north. So the North Pole here is going to get very, very little sunlight, if any sunlight, during this time. It's night the whole time. And down here, the southern hemisphere is having its summer. And the South Pole at the very bottom is having probably 23 or 24 hours of sunlight every day. So if you take this down again, now the more sunlight an area gets, the more opportunity it has to heat up. And so in summer, like it is here in the southern hemisphere, more of the Earth sees the sun for longer periods, so it sees more hours of sunlight, which helps to heat it up. So all again of this is notes. So during the summer, the northern hemisphere where we live, where Ireland is tilted towards the sun. Days are long and we receive more solar radiation. During our autumn, the northern hemisphere begins to tilt away from the sun. Days get shorter and temperatures drop as we receive less solar radiation. So in other words, we get less sunlight. That's what they mean by the solar radiation part there. During our winter, the northern hemisphere is tilted away from the sun. Days are short and temperatures are low because there is little solar radiation. So our shortest day of the year is in December, and people would say, oh, after that date you can actually feel the days getting longer, and you can. We can probably feel it a bit now. In our spring, the northern hemisphere begins to tilt back towards the sun again. The days grow longer and temperatures will increase as we get more sunlight, more hours of sunlight per day. So that, combined with the lines of latitude, helps to explain why areas closer to the equator are warmer always than areas that are further away from the equator. And then the tilting of the Earth on its axis helps to explain where our seasons come in. Our summer, when we're tilted towards the sun, and our winter when we're tilted away. And that also influences the amount of heat we're getting, as that is influenced by by the hours of sunlight that we get. Okay guys, make sure you get the notes taken down, please.